Hello everyone, welcome back to our channel. Today we are back with one more important string problem from the blind 75 DSA sheet. So the problem name is group anagrams. We will be solving it. First of all, we will see the problem statement, what it is saying. So the basically question is, we have been given an array of words. We need to group words that are anagrams of each other. So basically, what is the meaning of anagrams? If you guys have not seen the video of valid anagram, so it's my suggestion to see that video as well to get the clarity of anagrams. So let's discuss about what are anagrams. So anagram is a word formed by rearranging the letters of another word. Okay. For example, in this given array of strings like eat, tea, tan, ate, nat, bad, the words eat, tea and ate are anagrams because they are formed with the same letters like T, E, A. You can see the common things in these three these three words. T, E, A are common. In T also T, E, A is there, and in ate also we can see that these three letters are common. So in the words eat, tea and ate are anagrams because they contain the same letters in a different order. Similarly, tan and nat form another group and bat remains alone. So what is the goal in this question is basically we have to our goal is to efficiently group the anagrams together and return them as a list of list. Okay, so what could be the brute force approach for this type of questions? Let's discuss that. The question, I guess it's very straightforward and clear to everyone. So the brute force approach, like how can one think of it? So basically straightforward approach is to basically compare each word with every other word and we can check if they are anagrams or not, like we were checking in the valid anagrams question. It's that simple. So now the question is, how do we check if two words are anagrams or not? So we can simply sort the characters of both the words and we can compare them. If after sorting if two characters are becomes same, like you can see that in this eat and tea, if we sort these two words, so in output we will get AET and AET. So basically it's obvious that these two words become same. So if that case arises, so we can say that these two words are the anagram of each other. So that only I'm trying to tell what should be the approach. Like we can sort the characters of both the words and compare them. If they match, remember, if they match, they belong to the same group. We can do this for every pair, but you can think of it, this approach will be highly inefficient because sorting a string takes O of k log k, where k is the string length, and log n approach. Basically, if we use sorting operations, it's basically k log k. And if there are n words, we will check all the pairs, which will lead to an O of n square k log k. That will be too slow. The time complexity, which is too slow for the large inputs. So we will be avoiding using it. But yeah, this approach works for smaller inputs. Basically, if we are building a solution, so brute force approach is must before getting into towards optimal solution. But we will focusing on the optimal solution. This I have told you for knowledge purpose because it is necessary to understand, to know the flow of the question, how we can think. So if we now we will walk towards the finding the optimal solution of this problem. So how we will do this? Basically, we will do this with the help of hash maps. Okay, or we can say hashing. So optimal approach, how we can solve it basically by in brute force. What we were doing was basically we was comparing each word with every other. But now in this approach, we will use a hash map, that is unordered map, and we will store string and vector of string, basically in the form of key value pair. So idea is basically every anagram when sorted has the same character sequence, like we were checking in the brute force. So we will use the sorted version of those word as the key in a hash map and store all the words with the same sorted form in a list. So this way all anagrams will naturally grow together. I will show you all the dry run of the approach I am telling you. Basically the input array of string was like et, tan, 8, nat, bat. So what we are doing is the words are as input we can see like et, tan, 8, nat, bat. And if we sort these words, so sorted form will be for eat, it will be aet. So the sorted form will be aet and the hash map key will be the sorted form aet, and the group it will come under eat group. And second one, there is t, the sorted form will be aet, so the hash map key will be same aet, so it will be in the same group eat and t. Then third, tan, if we sort it, it will become and hash map key will be and. So this is the new group, that is tan, because the hash map keys are different, so we will put it into the other group. Next one is 8, so the sorted form will be aet and hash map key will be the similar to the first and second one, and it will come into the same group eat, t and 8. And in next one, the input string is nat and sorted form will be and hash map key will be and. So it is similar to the third one, that is tan, so it will come into the similar group. So similarly at last we have bat, and so the sorted form will be abt and hash map key will be abt, so it will be alone as there is no hash map key similar to abt earlier. So at the end the values in our map will be our result. These grouping values are the result. So output will be like it will come under similar hash map key strings will be in same in one group and the other one in other group, and bat, since it is alone, so it will be alone. So let's talk about the code, how we are solving it. Basically we are first of all we are creating a hash map to store the sorted string as key and anagram words as values. So for unordered map we have string and anagram groups. Basically string is key and anagram words as values. Then after that we will iterate through each word in the input list, that is string word strs for each loop. So basically we are copying the original word, storing the sorted word. Basically this is variable which will store the original word and making the copy of it. After that we will sort the characters of the word. Okay, so after sorting it we will store the original word in the hash map under the sorted version as the key. Okay, after that we will extract the group anagrams from the hash map. That is as we can see from after the grouping of these, if we after founding these words and forming them into group, what we need to do is basically we will create vector string result. So basically this is the vector of vector strings and we are taking storing it into the result. So what we will do, we will take the for loop and after that we will push back the result, basically the entry of those words which we formed using the group. After that we will return this result which we have initiated here, so in order to get the return the final list of grouped anagrams. So if we talk about the time and space complexity, basically it is clear. Sorting each word, for sorting a word takes O of k log k, where k is the maximum word length. And for processing all words we will iterate n words, leading to n O of n into log k. And storing in a hash map, basically O of n additional space for storing words in group. So if we talk about final time complexity, the time will be O of n into k log k and space will be O of n into k for storing the words in the hash map. The approach is much faster than the brute force, so we can go ahead with this approach. And if you guys understood the solution, please hit the like button and share it with the other students as well. Thank you.